Welcome back to our series on AI and machine learning. In this lesson, we'll explore the essential tools and frameworks used in the field of machine learning. We'll discuss popular tools like TensorFlow, PyTorch, and scikit-learn, provide a basic introduction to how they are used for building and training models, and offer guidance on choosing the right tool based on various factors. Let's start with TensorFlow. TensorFlow is an open-source machine learning framework developed by Google. It is widely used for a range of tasks, from training deep neural networks to deploying machine learning models in production. TensorFlow offers robust support for both deep learning and traditional machine learning algorithms. One of its key features is TensorFlow's ability to run on multiple CPUs and GPUs, making it highly scalable. TensorFlow also provides a high-level API called Keras, which simplifies the process of building and training neural networks. Next, we have PyTorch. PyTorch is an open-source machine learning library developed by Facebook's AI Research Lab. PyTorch has gained popularity for its dynamic computational graph, which allows for more flexibility and ease of use compared to TensorFlow's static graph approach. This makes PyTorch particularly well-suited for research and experimentation. PyTorch also provides seamless integration with Python, making it intuitive for Python developers. Another important tool is scikit-learn. Scikit-learn is a widely used machine learning library for Python, built on top of NumPy, SciPy, and Matplotlib. It provides simple and efficient tools for data mining and data analysis. Scikit-learn is particularly well-suited for traditional machine learning tasks, such as regression, classification, clustering, and dimensionality reduction. Its easy-to-use API and comprehensive documentation make it a great choice for beginners and for those working on smaller-scale projects. Now, let's discuss the basic usage of these tools. Building and training a model typically involves several steps: data preprocessing, model building, training, and evaluation. For instance, in TensorFlow and PyTorch, you would start by importing the necessary libraries, loading and preprocessing the data, defining the model architecture, specifying the loss function and optimizer, and then training the model using the training data. Scikit-learn follows a similar workflow, with a strong emphasis on simplicity and ease of use. Choosing the right tool for your project depends on several factors. One important consideration is the project requirements. For example, if you're working on a deep learning project that requires flexibility and dynamic computation graphs, PyTorch might be the best choice. If you need a highly scalable solution for production deployment, TensorFlow could be more suitable. For traditional machine learning tasks, scikit-learn's simplicity and efficiency make it an excellent option. To summarize, TensorFlow, PyTorch, and scikit-learn are powerful tools for machine learning, each with its unique strengths and use cases. Understanding their basic usage and knowing how to choose the right tool based on project requirements, ease of use, and community support can help you effectively build and deploy machine learning models. In conclusion, familiarizing yourself with these essential tools and frameworks is crucial for success in machine learning. Each tool offers valuable features and capabilities that can accelerate your development and research efforts. In our next lesson, we'll explore practical applications and case studies of machine learning in various industries. Stay tuned.